All right, welcome to day 6, guys. You thought that you had learned everything there was to know about circles, but it continues today. We're going to add some additional relationships, including tangent, chord, and our secant relationships. So first of all, let's start by kind of loading up with some just definitions here. So when we talk about intersecting a tangent and a chord, first of all, if you remember from previous lessons, a tangent is a line that's essentially just like grazing the circle at one point. And then a chord is completely contained within the circle. Its endpoints are on the circumference of the circle. So there's special relationships that are established when you have a tangent and a chord for a particular circle intersecting like this. So we say that when a chord intersects with a tangent, and that's obviously on one circle, then we say the measure of each angle formed, is half of its intercepted arc. So let's actually make sure we elucidate what angles we're talking about. So when we're talking about the angles that are formed, we're saying in this case like angles 1 and 2 here. And so the intercepted arc, remember that's from a previous lesson as well. That's like the arc which is generated by that particular chord. So whatever the measure of that particular arc is, half of that measure will be the angle 1 here. And then for arc C, half of that measure would be angle 2. Maybe let's just kind of spell that out as well. So we can say that the measure of angle 1 is going to be 1/2 the measure of arc B in this case. So if we know that its measure, we can just chop it in half. And then the measure, I don't know why my handwriting's, I've been sick, guys, and my handwriting is off. Everything is off. All right, measure of angle 2 is 1/2 the measure of arc C. Okay, so that's what we have there. So now let's actually put it into place. So if I want to find the measure of angle 1, again, we are looking at angle 1 here as being formed between a chord and a tangent. So we know the relationships we just discussed are going to be in play here. So we say that the measure of angle 1 is going to be 1/2 of its intercepted arc. So in this case, the intercepted arc is 172 degrees. So we're taking 1/2 of 172, which is measure of angle 1, 86 degrees. Okay, so that's kind of the nature of, I don't know if you've noticed the theme in this unit. It's just really pretentious, like theorems and descriptions and just the terminology. But when it comes down to it, it's not that bad, right? You're literally just finding the larger arc, chopping it in half. Okay, next one here, we want to again find the measure of angle 1. Notice that the information that they're giving us is actually pertaining to what would be like an angle 2 here. So we have to find what the measure of the intercepted arc, like what's that arc across from angle 1. If we know they're 360 degrees in total in a circle, then if I just take 360 minus that 128 that I'm dealing with, then that's going to leave me with 232 degrees for the remaining arc. So the measure of angle 1 is 1/2 of its intercepted arc, right? 1/2 of this guy here, which is 232. So if I just chop that in half, then I'm seeing that the measure of angle 1 is 116 degrees. And that's it. So as long as you know that arc across from the angle that's generated by that chord and tangent, then you can just chop it in half. Okay, now let's look at another relationship. So we have interior intersection of two chords. So no longer a tangent, but we have like these two chords in the middle of the circle here. You want to think of these as, like, notice these 4 angles in the middle here are kind of essentially modeling like the vertical angle relationships that we saw in last semester. So let's go ahead and say we're going to liken this to vertical angles. And we know specifically that vertical angles are congruent, right? So vertical angles are congruent, meaning in our diagram here, angle 2 is going to be congruent to 4, whereas 3 would be congruent to 1, because they're essentially vertical angle relationships there. The other piece that we want to say is that interior angles, so I'm going to mention that interior angles, their measure of these interior angles is going to be 1/2 of its intercepted arc plus its vertical angles arc. And that's, for those of you who are forgetting, grammatically that's possessive, not plural. So we're saying the vertical angle that is, or the angle that is vertical to a given angle, its arc is the other one that we pull into play. So you're just pulling 2 into this calculation. It's not a very formal definition right there. So if I were to just look at this diagram specifically and give you kind of a takeaway formula on this, we're going to say that the measure of angle 1, which, let's kind of erase some of this mess. Measure of angle 1, which would be right here, is going to be equal to 1/2 of its arc, which is, remember, the one across from it, so 1/2 of the measure of arc AB, plus its vertical angle, which would be 3, the arc that pertains to that guy, which is CD. So measure of CD. So it's kind of like you're taking an average, essentially, of the 2 arcs that are across from one is exactly across from the angle that we're solving for. The other one would be its vertical angle. But so you're going to add those 2 measures together and cut them in half. If I were to look for angle 2, so now let's shift gears to finding this guy instead. Okay, so measure of angle 2. Now I'm taking 1/2 of the sum of this arc with this arc. So again, it's like the arc that's across from it, and then the arc across from its vertical angle. So measure of angle 2 is 1/2 of the measure of arc AC plus the measure of arc BD. So very similar. Notice if we look back at what we were doing before, like that theme of multiplying by 1/2 is coming into play again, but now you're just summing 2 different arcs. Okay, so if I'm looking for the measure of angle 1 here, notice that I'm just going to be, and not that you have to draw these arrows, I think it's just kind of helpful to illustrate which measures you're going to use. So you want to use the arc across from angle 1 and the arc that's across from its vertical angle. So I'm going to say here that the measure of angle 1 is 1/2 of its arc, 131, plus its vertical angle's arc, which is 33. If I add those bad boys together, chop them in half, then measure of angle 1 is 82 degrees. Okay. Again, notice that this is very, very close to like a central angle concept where the angle would be the same as its arc, but this is not a central angle because it's not at the very core of that circle there. So that's why we have to use these other relationships. Oh, it doesn't even look like a circle. That's kind of distorted there. Okay, now we're looking for angle 1, right? We would typically add the arc across from it and then the other arc, but those values are currently missing. So instead, let's go ahead and designate a 2 for a second and solve for 2. And then we can use that information to go back in and solve for 1. So I'm going to solve for 2 first, knowing that I have to use its arc and then its vertical angle's arc. So I'll say that the measure of angle 2 is 1/2 of 97 plus 115. If I add those together and chop in half, measure of angle 2 is 106 degrees. Okay. So if I add this label in, here's 106. And we know that, remember we said that those kind of the relationships of vertical angles and even supplementary hold. So angles 1 and 2 here are actually falling on a nice straight line, meaning they're supplementary. So measure of angle 1 is just going to be 180 minus angle 2, which was 106. So that gives me 74 degrees. So notice how all of the geometry past comes back to haunt you again. Okay. Now we're looking for measure of an arc instead of an angle. So we're going to find the measure of arc AB. The angle they're giving us is 88 degrees, so that's like this angle here. So if we think about the opposing measures that we would be using in a calculation for these intersecting chords, it would be the two that we're pointing to here, right? So I know that my generic setup is saying like the measure of angle 1 is 1/2 of its arc plus, we'll say its vertical arc. So in this case, 88 degrees is the measure of the angle I'm dealing with. And I'm saying that's 1/2 of the arc that I don't know, that's measure of angle AB, plus the measure of the arc that's given, which is 124 degrees. So now I'm just building a algebraic equation to solve where my variable is this guy, essentially, measure of arc AB. So I need to get rid of that 1/2. If I multiply both sides by 2, then we get 1. I told you, sick brain, it's moving in slow motion. 176 equals the measure of arc AB plus 124. Again, we're trying to isolate the unknown here. So if I subtract 124 from both sides, then we get 52 degrees equals the measure of angle. Or not angle, it's arc AB. Cool. So again, it's not too bad as long as you know how to approach the problem. Okay. All right, here's some more fun because it always, that's how geometry works. Now we're going to look at exterior intersection. So, back over here we had interior intersection with two chords. And now we're going to have exterior intersection. It could be of two tangents like we have in this case. These would be two tangents. A tangent with a secant, and then two secants. But regardless of the type of relationship, so there's like 3 different cases here, but the approach will be the same every time. So we're just going to say that the measure of the exterior angle that we're looking for, so in this case it would be like angle A, angle A, angle A. In all 3 of these cases, it's just going to be equal to 1/2 of its arc minus its vertical arc, which is going to be a little trickier to envision since it's not on the inside of the circle this time. But another way to formulate that is measure of angle A is going to be 1/2 of the measure of arc BDC. So it's like we're taking this whole guy in green minus the measure of arc BC, which is the piece in orange here and now red. So not vertical in the sense, well, or let's say that like verbally it would make more sense to shade it's the arc across from it versus like if you were to create an interior situation there, it is, in a sense, it's vertical angles arc. So we're just taking the one across from it versus the residue or the remnants of the rest of the circle and subtracting the 2. Okay, so again, since it's not like a very organized formula, because it kind of just depends on how we're naming things, it will make more sense when we look at examples. So if I'm looking at number 4 here, again, I want to find the measure of angle 1, which is right here. Okay, the 2 arcs that are created, the arc across from it is this 92 degree arc, and then the other little piece that's, we'll say, between the wedge is 43. So in this case, I'm saying that the measure of angle 1 is going to equal 1/2 of the arc across from it, which is 92, minus that little piece in between the wedge, which is 43 degrees. So if I subtract those 2 and chop it in half, then I would see that the measure of angle 1 equals 24.5 degrees. Okay, so that works out nicely if both of those arcs are labeled. This one though, because now we're looking for, again, angle 1, we want to take the measure of this arc, which we don't know, it's not actually given to us, and subtract the measure of this arc, which is given to us. It's like the minor arc in a sense. But to get the other one, notice that we do have 80 degrees. We have 60 degrees here. There are 360 degrees in a circle. So if I subtract out the angles that are given already to me, so 360 minus 60 plus the 80, then I will get the highlighted green measure. So if I subtract 60 and 80 from 360, then I should get 280, right? 280, yep, okay. So this guy here is 280 degrees in green. So now when I go to build it, I'm saying that the measure of angle 1 is 1/2 of its true intercepted arc, which is 280, minus that little interior arc, which is 60. So if I subtract the two, I'm taking 1/2 of 220, chop it in half, I have 110 degrees for a measure of angle 1. Boom, okay. Last one, again, they're giving us this ambiguous situation there where we don't know what is this measure. But notice in this case, just because we're dealing with two tangents, the points where these little tangent lines are intersecting the circle is completely splitting the circle into like the two arcs of our calculation. So if I have 66 degrees right here used up, then I just need 360 minus 66 to get that highlighted piece. So if I subtract that, that's 294 in green, right? Because that comes from subtraction here. So those are the two arc measures that I can use for my calculation. So saying that measure of angle 1 is 1/2 of 294 degrees minus 66 degrees, right? The larger arc and the smaller one. And if I add those up and divide them in 2, that's 114 degrees there. And that would be it for that. Okay, just a little summary at the bottom here, because we've kind of built on some of the other things we've studied in this unit. So if we're talking about angle location, like what angle are we looking for? Where is its vertex located? If it's located in the dead center of the circle, like here's my circle, dead center, that's not even, oh my goodness. Try that again. Like the perfect center of the circle, still not, but you get the idea, right? And we're looking for like this angle, then we call this a central angle. It's just its name. And then to its relationship to the arc that's across from it, like this arc here. The arc measure equals the angle measure. So we just say that the arc, let's spell it out. Arc measure equals the angle measure. So you don't even have to do any solving in a case like that. They are exactly the same. Okay. It's kind of vague, isn't it? If it's on the circle, is what that should say. So if we have our circle and there's an angle on it, right? So we're talking about like, let's see if we can find a better illustration of it. That's what we were doing really in this first scenario here, right? So something like a tangent formed with a chord. So if I have like a chord, I can't even draw that. That was the case, so chord with a tangent situation, okay? Then we say that this is an inscribed angle. Inscribed angle, or it's a tangent chord relationship. Yeah, so I guess two scenarios. Like the tangent chord dynamic we introduced today, and then the inscribed angle was from our previous lessons. So in this case, we say that the angle measure, angle equals 1/2 of the intercepted arc. Okay, then we have the dynamic of inside, but it's not the center. That one I can confidently draw. So say it's like over here, right? We have like the the two chords going on here, like an angle like this. This we just call an interior angle. So it's not central because it's not perfectly in the middle, but it is interior to the circle. And then its measure is 1/2 of its arc plus its vertical arc. Okay. Versus one that's on the outside. That was like that last relationship we talked about. So something like this, we're looking at this angle, right? This is an exterior angle. And we say that now its measure is actually going to be 1/2. It's very similar to the previous calculation, but 1/2 of its arc minus, well, or we could even say too, because we kind of did away with the vertical nomenclature, let's say this is the outside arc. Outside arc minus the inside arc. And that's really the better way to explain that. Like if we go back up here, I think I was saying its arc minus its vertical arc before, if you'd like to think of it that way, but really like probably a more straightforward way is to just do 1/2 of the outside arc minus the inside arc. And that was that formula for the exterior intersection. So a lot of really specific kind of relationships here, but hopefully that was pretty straightforward with things. Thanks for watching, guys.